Hi everyone, I'm Tom Dodd. I'm here to talk to you about H3, to divide or not divide, and that's a question. So H3 in the context of hybrid event bed models. In the original work by Horton et al. 2009, H3 was described as being deposited by cohesive debris flows that are locally modified by sand injection from beneath and they had a partly reworked top. Since that original work, a lot of people have looked at hybrid event beds in general using fast track model approaches and have shown variability across the deposits in general, but also within the H3 unit. They've shown that H3 varies in terms of composition, character, and texture, and often those variabilities change in terms of transitional boundaries across the fan surface. But what if H3 debris isn't a single unit? What if it has internal subdivisions? Some recent studies have suggested that might be the case. Hussain et al. 2020 used XRF profiling to show that clay varied upwards within a single H3 unit and used on that basis discriminated between H3A and H3B. The advantage of this work is that clay composition can be shown quite clearly in these graphs. But can this be observed visually? Do you need XRF profiling to show this? And hopefully I'm going to show you that you can see variability using high quality core data from the North Falkland Basin. All of my examples are from the early Cretaceous fan systems of Casper and Beverley. The examples are from the medial to distal parts of the fan. Some are from below or above the lobe axis deposits. Some are from the fringes. And others are from channel exits. But enough about that for today, that's another story. We're going to dive straight in and look at some core. So the examples from the North Falkland Basin. Here, pick two really nice ones for you. H1 and H1A shown at the bottom here, H5 and H5 on these two examples. They bound the upper and lower deposits of the hybrid event bed. H2 is absent in both cases, typical for most hybrid event beds anyway. H4 is absent also. So within that framework, this is H3. H3 can be subdivided into three units, A, B, and C. A has a low mid-matrix composition, B is slightly higher, and C is much higher. The same can be seen in this example here. And those changes in mid-matrix clay component happen across quite sharp boundaries that are dotted in for you here. And if you believe those boundaries to be there on the basis of where I put them, you also spot some extra changes in terms of sedimentary character and composition. H3B has these sand injectite features in here, mud clasts, and possibly has a mounded topography at its upper contact that shows a spatial association with these sand injectites. That association can be seen in this example in here. H3C commonly has these elongate mud clasts, quite a high mud matrix component, more isolated injectites. You know, those examples can be seen in here as well. Some of those sand injectites are sheared out. So there's textural and compositional variability shown within each of the subdivisions of H3 as I've mapped them out. But it's those boundaries which are key, those sharp boundaries that show quite abrupt changes in composition and character. There's also angular contacts between some of the subdivisions. So in this example here, A, B, and C, they show angular relationships. Some are erosive, so this H3C in here erodes down into H3B. Those sharp boundaries are absolutely key because they show instantaneous changes in flow conditions, time gaps or breaks in deposition, or erosion or reworking of sediment. The angular boundaries definitely show erosion. They show changes in flow, rheology, or direction. The time gaps or breaks in deposition, and they indicate pellic contemporaneous deposition. All of those things to come together that indicate that internally within H3, you can define separate units, flows, or beds. So my current thinking is the H3 debris is composed of multiple layered deposits with sharp, sometimes angular contacts. They're generated by multiple events or flows, each cohesive but with quite different strengths and flow properties. They probably occurred as part of the same overall flow event but with discrete flow units. So can partition of debris happen? Do they have a pulsed end with further segregation of H3 debris, particularly at the tails? And does this have an impact on modelling the distribution within the fan systems? If those fast track model approaches have to be further subdivided, does it change how you view the spatial and temporal evolution of these deposits? So I think there is an update to the model to be had. And possibly we could add in some more formalised units within the H3 models. So with that, any questions? Thank you.